Okay, let's continue with the powder bed fusion processes. We were about to finish this chapter. We have just few slides left. Let's briefly talk about the capabilities and some limitations of these processes. First of all, as you know, the process is complete in a powder bed. And we said that once you have these powders around the parts, even while printing complicated shapes, you don't need to have support material, especially for the polymers one, since the powders around will support these overhanging regions and some difficult features. So it is a nice property. We said that for the metal ones, people these days prefer to use support structures to have better dimensional accuracy and to dissipate the high energy, high heat, so that they will have less shrinkage and or uniform shrinkage. But for the polymers, we don't need to use extra support structures. Another advantage with the help of this, especially again with the polymers, you don't need to do post-processing. You don't need to, let's say, do curing. Just you can do a little cleaning operation and you will be done. Another advantage with the help of this powder bed feature, you can have intricate shapes produced in a shorter time in an easier way. But the thing is that since we are using powders, they're not as accurate as SLA process or photopolymerization processes. We will have like kind of a grainy surface on these powder bed fused parts. And another problem is that once your powders have low thermal conductivity, you'll have high accuracy. Can anyone tell me why we have such a property? Why we have high accuracies with low thermal conductive powders? Any volunteer?
If it's high thermal conductivity, the powder next to what we want, the position we want, will also melt and then fix together.
Yes, you're right. This is actually the main thing. Assume that this is layered and you have many powders around. And if that material has, assume that the inverse first, the high thermal conductivity. If this powder has high thermal conductivity, then once the laser is actually reflected on it, then it will dissipate its heat to the neighbor powders. And if that's the case, then they will be remelted. They will be kind of fill all the gaps, but the accuracy will be lower. But if you have low thermal conductivity, then that means probably the powder will only transfer the heat to just the neighbors around it, but not the other ones far away. If that's the case, if you have powders with low thermal conductivities, then the accuracy, the geometrical accuracy, dimensional accuracy will be better than the case you have high thermal conductivities. Another problem we have with powder bed fusion is that the part construction time is longer compared to other FDM, FFF, or SLA, since you are going to fill the bed completely with the powders, and depending on the height of the object, even you are just printing a pencil, you need to fill the complete bed with powders. But if you do feasible programming, feasible planning, then you may have many parts after each other on top of each other. Then you may eliminate this disadvantage. So this is actually the last thing, the kind of an advantage, since in the same bed you can print a pencil and another box at the same time. That's your part, and you can have many small parts on top of each other. Even they have different shapes, different orientations, you can print them at the same time. And with the help of it, you can decrease the overall fabrication time, and it may be kind of an medium-sized production, medium batch production. So these are actually the main limitations and advantages of powder bed fusion process. But what is next for these type of processes? We have a new company working on a different powder handling system, they use two different types of powders at the same time. That's why they call their process as multi-powder printing process. In this illustration, you can see that we have blue powders and gray powders. They do not give the details of their powder dispenser or powder handling system in a detail, but we can assume that they have two kind of rollers. But this time, these rollers are not going exactly on the plane. They are a bit above the plane, and they are depositing these powders in a very controlled manner. They know how much they are depositing, and with the help of this feature, they can actually deposit a specific, let's say, powders to a specific region, and the other regions, the remaining region, may be filled with gray, let's say, powders. So it's a very nice property, and the company is called Aerosynth, and they have actually started doing this job around 2015. Right now, they have a much better, let's say, system. I want to share you their website now. This is their website, and each day they perform new, let's say, applications. I think here's a video. Yes, this is their special system. With the help of it, they can deposit two different powders at the same time. I'm sorry, guys. Yes. Here's another one. They use, as you see, titanium and aluminum ceramics at the same time. Here's another one, copper and stainless steel. And they have even more complicated shapes. So this is the feature of powder bed fusion systems. Even they joined copper with ceramics, and here they have some kind of glass, colored glass. And they can also have such gradient transition between two different materials. We don't have a pure transformation, but this is done in a gradient manner. So their website is quite informative. You can have a look at different applications. Here you see, for instance, there are some cube shapes. Some part of it is copper, some part of it is steel, I guess. And this is showing you the details of their powder handling system, but not in a detailed way. There's another small video about it. Dual metal laser powder bed fusion process. So they are coating the bed actually with copper and steel, I guess. And now they will do melting. Dual metal laser melting. And I want to show you some use cases, or there was a kind of an explanation. I think this was the thing I want to show. And another important issue about their system is that they do not sell the complete machine. They only sell their powder handling system, and they can actually make it usable on any kind of laser wet fusion system. Copper steel printing. Some examples, some nice figures, but this wasn't the thing I want to show. Yes, here it's. They are discussing, they're comparing their system with doctor blade. This is doctor blade, and this is counter-rotating roller. As you see in the conventional ones, we have some shear forces on the plane, but right now they're not touching the build table or the powder bed. That's why we don't have any shear forces. They can have multiple materials. Their advantages are listed here, but in fundamental, basically, these are the basic things. They can use different materials at the same time, or the same material but different size of powders may be used at the same time. And let me show you the slide once again. For instance, instead of using different powders with different type of materials, they may have small sizes here and larger size powders for the gray side. This is also possible in their system. Any questions, guys, on this new powder handling system? Okay, so let's conclude this chapter. As you know, the powder bed fusion processes are one of the first additive manufacturing processes. It's quite popular. It's mostly used for prototyping, and these days we start to use for some end cases, and it's sometimes quite competitive, especially for low to medium volume of production, since if you have a larger building volume, you can produce many of the small parts in a short amount of time. And these days we have mainly companies focusing on metal-based systems, especially for aerospace industry and biomedical industries.